Physics 2054, Fall 2011, Exam 1, Question 1. Before you start this question, or the exam in general, you should write down a table that I find very useful. And that relates the force, the electric field, the potential energy, and the potential. So you can write this chart. Now, if you write it this way, then everything on top has a dependence on Q1, Q2, and everything on the bottom has just Q1. Everything on the left has dependence on 1 over r squared. Everything on the right, 1 over r. And all of these values get multiplied by k. So how do you read this? You say, OK, what's the force, for example? Well, it's in the top, so it's Q1, Q2. And it's in the left, so it's 1 over r squared. And then you multiply by k. And that's the equation for force. And you can do it for all of these. So now we get to the actual problem itself. It says that you have 3 positive charges arranged in an equilateral triangle with side length 1. And the charges are A and C have 1 coulomb, and B has 3 coulombs. OK. And it asks to find the ratio of Fy over Fx. So let's start with the magnitude of Fy. So Fy is equal to the component, so F sub y for AC, right, between these 2 charges, and Fy between A and B. Now looking at C, it's in the x-axis with A. So you know off the bat that the y component of the force is equal to 0. And the force for the x component, or for AB, that's a bit more complicated. So let's calculate that. The total force between A and B is, as we see over there, it's K times Q1. Let's call A Q1. So times 1 times Q2, which is 3 coulombs, over the distance squared, which is 1 squared, which is equal to 3K. OK, but we need the y component. So we draw a line there, and we've suddenly got a 30, 60, 90 triangle. So the y component of the force is equal to the total, 3K, times the sine of 60. And this is equal to 3 root 3 k over 2. OK, so far so good. So that's the total magnitude of Fy. Now we go on to Fx. Fx, which is equal to the component from this and the component from these 2. So since AC is entirely in the x direction, we know that the force is equal to K times Q1, which is 1, times Q2, which is 1, over the distance, 1, squared. And the total magnitude of the force between A and B, let's just call that Fxab. Now, before we figured out that the total force between AB was 3K. So we can use that. And now using trigonometry, we know it's going to be 3K cosine 60. So FXAB equals 3K cosine of 60, which is 3/2 K. So the total FX equals K plus 3/2 K, which is also the same thing as 5/2 K. Great, now we just divide the two. Fy over Fx. Of course, we're using the magnitudes. With vectors, it wouldn't really make sense. Fy is 3√3 over 2 K, and Fx is 5/2 K. And we can look at it, cross out the 2's, cross out the K's. So this is equal to 3√3 over 5, which is the same thing as 1.04.